Alrighty, so we are working on arithmetic sequences and series, okay? So the way you pronounce that again is arithmetic, okay? Not arithmetic, arithmetic, okay? Sequences and series. We're on worksheet 9-2, okay? I do have a do now here, all right? Which I'm going to skip because we kind of did that, but I do want to look at this guy, okay? It says, how many cards are there in each row of the house, okay? So if you look here, this is our first row, right? So our first row has 1, 2, 3 cards, right? And that's your A sub 1, okay? So I'm going to keep using that notation. So the first term is A sub 1, right? And this is my N, okay, that I'm going to keep using. So this is first, then this is my second row, right? So that's going to be the second, and that's going to have 3, 6, right? And that's A sub 2. And then this one has 3, 6, 9 in the third row. So if I were to ask you, what would you expect, right? To be in the fourth row, let's say, right? You could notice a pattern that each time we're adding a triangle of cards, right? Which is 3, so therefore this would be 12. So here you can kind of see that your common difference, the way this is changing, is you are adding 3 cards each time. So D is 3, okay? That's your common difference, all right? So this example here, this sequence that we have, okay, so this is my N, this is my A sub N, all right? This is an example of an arithmetic sequence, okay? Because we have a D value. You are adding 3 each time, okay? It happens to be 3 cards, but so when you add the same constant each time, that becomes an arithmetic sequence, okay? So here it says, this is an example of an arithmetic sequence. In an arithmetic sequence, the difference between the consecutive terms is constant, right? And the constant difference is denoted using a D. So you see how I said D equals 3? Usually we would look at this and go, we're adding 3. So now we're just going to call that the common difference, all right? So for an arithmetic sequence, the biggest thing is there needs to be a constant increase or decrease, right? So that's what we're looking for. So this is the first type of example you'll see on your homework, right? It says, tell whether the sequence is arithmetic. So remember, sequence is just a list of numbers, okay? So this is your first term, your second term, your third term, your fourth term, your fifth term, okay? So if I take a look at this guy, you might be able to see that this is arithmetic already. So are we adding or subtracting? The same number. In other words, is there a D value, okay? So if I take a look here, the way you can always check for a common difference is there finding the difference of each of the terms. Now what's a little bit weird about that is you always work backwards. So I'm gonna do 7 minus 0, and that gives me 7, right? Then if I look at this one, right, the second, the third and the second, right, that would be 14 minus 7, that gives me 7, right? And then 21 minus 14 equals 7. And then 28 minus 21 is 7. So you can see each time the difference is common. It's the same value, okay? So, or you could have just seen that the pattern here is I'm adding 7. That's fine too, okay? But if you can't figure it out, then you're going to do the subtraction. So to find D, you're going to take a term and subtract the previous term. Okay, the fancy way to say that is to take A sub N and subtract A sub N minus 1. Because if you think about it, like if I take, let's say the N term was 4, right? And then I do 4 minus 1, that gives me 3. So that's a fancy way of writing it, but you can just remember this. So you choose a term, right? Each of the terms, and you subtract the previous term. Now, if I take a look at this guy, right? Well, this, right, is like +2. This one is +3. You could also do 3 minus 1 and then 6 minus 3, but you would get, right, a different increase. So this is not arithmetic because the increase is not constant. Another way to say that is there's no D value, okay? Here you want to say yes, because, let's just be /C is because the increase is constant. Or you could say D is 7, okay? So if you can identify D, that means it is arithmetic, okay? All right, if you can't identify a D, then it is not arithmetic, okay? So there's two very popular sequences that we're going to talk about. So this is the first one, arithmetic. Tomorrow we will talk about what's called a geometric, okay? But the first thing is, can you identify, all right? So if you take a look at our next page, right? If you look at the first guy, right, I can see that one. If I do 8 minus 1, or if I just look at the increase, that's going up by 7, right? If I do 27 minus 8, right? What does that give me? It definitely does not give me 7, right? So this is not arithmetic. No D value, okay? If I look at this guy, though, I can kind of see, right? You can see the pattern of +2, hopefully, right? So therefore, this is yes, it's arithmetic. And you could say one of two things again. There's a constant increase. There could also be a decrease, just so you know. In all these examples, it's increase, but there's a constant increase, okay? Or you could say that D is 2, okay, as your explanation, all right? And then, last but not least, we'll skip 3, but that's the idea, okay? Now, what we want to do is we want to write a rule. Now, on your homework, you had to write a rule for yesterday's homework, but it was kind of sometimes tricky to figure out the rule. So what you need to do here instead, okay, is if it's an arithmetic, we have a formula that we can follow, okay? This is the rule for an arithmetic sequence. Sometimes they call it the explicit rule, so just another way to say that. But this is the rule for an arithmetic sequence. And if you take a look, they're using this a sub n and a sub 1, okay? So if you remember, a sub 1 is always your first term, okay? And all we gotta do is plug into this, okay? A sub n is the term, right? The nth term. So whatever term we're kind of looking for generally, okay? This is where the term is in the sequence, okay? So first, second, third, fourth, okay? That's your n value. And then D is our common difference, which is how it is increasing or decreasing, okay? So if you take a look at this guy, right? Write a rule for the arithmetic sequence. So we don't have to think about it. We know there should be a D. And then find a sub 9. So when I see this little sub, that's telling me that I'm looking for the 9th term. N is 9, okay? So the first thing is, this is like kind of 2 steps that we're gonna do. What you want to do is first write the rule, okay? So to write the rule, you need to know all these things, okay? So the rule a sub n, we're not going to know, okay? Because we're writing a rule, so we leave that there. But a sub 1, right, if you take a look, That's the first term, so that's 20, right? Then n, we're gonna leave as well, okay? Because we're writing the rule. So these two will stay when we write the rule, n and a sub n, right? You're not gonna plug any of that in. Then we look for the common difference, okay? So if I take a look here, what's the pattern? Well, if I work backwards, right, it's actually 18 minus 20 equals -2, and I don't have to check the rest because I know it's arithmetic. So if you look, the pattern is we're decreasing by 2 each time. So there is a common difference, it's just now we're adding -2, okay? So D is -2. Then I take it and I plug it right into my formula, okay? So when you're doing your homework, you should have this formula handy, okay? That D I put in parentheses because n minus 1 and the D are being multiplied. So we don't know a sub n because we're writing a rule. We do know a sub 1, that's 20, so I plug that in. Plus we don't know n because again we're writing the rule for the nth term, okay? And then D is -2, okay? Then I'm going to ask you to simplify that. So if you take a look here, do you see how it's a number multiplied by n minus 1, a binomial? So we're going to distribute here. Okay, so you're always going to distribute. It's the same steps every time. So a sub n is 20, right? And then I've got -2 times n, so minus 2n. -2 times -1 is plus 2. And then I simplify, so I get a sub n equals 22 minus 2n. And that's my formula, okay? So when you write your rule or your formula, right, you should see the -2 here, okay? And yeah, so this is my rule. Now the second part that I'm gonna do, so that was the first part, write the rule. So there it is. Then the second part is to find a sub 9. Okay, so using the formula, we're going to do a sub 9. So now we know, using the formula we wrote, that n is 9, right? Because we're looking for the 9th term. So a sub 9 is 22 minus 2 times 9, right? So then a sub 9 is 22 minus, what's that, 18? So a sub 9 is 4, I believe. So there's your answer, okay? And if you think about that, that kind of makes sense because here you have the first, right? This is a sub 2, a sub 3, a sub 4, and we're decreasing, right? So by the time we get all the way to the 9th term, it's very possible that we would have something as small as 4, okay? So if it's decreasing, right, your sequence, it should be a lower number for a later term, okay? So now take a look here, write the rule. So there we're gonna use a sub n equals a1 plus n minus 1 times d, okay? And then the second step, so that's our first thing, then our second step is we're gonna find a sub 12, okay? So when we're writing the rule, remember, we don't know a sub n. We do know a sub 1, right, which is 3. We don't know n because we're writing the rule, so we don't know those. And then d. So if you take a look here, the pattern, right, what am I doing each time? Is I'm adding 2, right? So d is 2. So now when I plug in, a sub n equals 3 plus n minus 1 times 2. And then I'm going to distribute the 2, so it's the same steps as up above. So a sub n equals 3 plus 2n minus 2. So then a sub n is 1 plus 2n. And it doesn't matter what order you put them in. You could do 2n plus 1. It doesn't matter, okay? But any n value, if I plug it in, will give me that term. So now if I go here, a sub 12, they're telling me n is 12. I'm trying to find the 12th term, okay? So a sub 12 equals, I'm going to use my formula, 1 plus 2 times 12. And then, what is that, 1 plus 24? So a sub 12 is 25, okay? So those are my two answers. So if you take a look here, right, and that kind of makes sense because we're increasing by 2. By the time I get to 12, right, I could potentially be, right, makes sense that I would be at some value higher, larger value of 25, okay? All right, so that's writing the sequence, okay? Now we're gonna talk about series, okay? So series, if you remember, we talked about it briefly yesterday, is just when you take a sequence and you add it, okay? So if we have an arithmetic sequence, right, one that's constantly increasing or decreasing, the arithmetic series is just the sum of those terms, okay? And then we have, again, a formula, okay? Now they're getting very technical here. It's the sum of the finite arithmetic series because there has to be an end, okay? Otherwise you'd be adding to infinity, all right? But you can see the same type of notation that we had in our previous formula, okay? So this is something to have handy as well. But remember, n is our, where it is in the sequence, right? So the place, how did I explain it last time? Where the term is in the sequence. So that's n. Where the last, and I'm going to be very specific, term is in the sequence. And I'll show you what I mean. A sub 1 is our first term. And we are summing through the n terms, right? So if I have a sub n, that means this is my last term, okay? So this is my last term, which is the nth term, okay? And that's the most important part about this, so we'll take a look at that. And then we divide the sum of those by 2, right? So we do our parentheses, and then we'll multiply by n, okay? So I kind of talked about this yesterday, all right? We talked about the quick way to add a sum. So if you remember this sheet that we had, okay? Do you remember how I did my partial sums, right? And I took the sum of these two? That's basically what this formula is. I'm adding the first and the last terms, right? So that's where the a sub 1 and the a sub n is coming from, okay? And then I'm taking, right, the n minus 2, n divided by 2 is the number of terms divided by 2, exactly half of them. So you always have half the partial sums, okay, of the number of terms. So that's what that formula comes from, okay? You don't have to know that. I just wanted to go through it briefly. You really just need to know how to use this formula and what all the variables stand for, okay? So if we go back, we have find the number of cards in the first 20 rows in the house of cards from our previous example. So if you take a look here, I have here, we wrote out this sequence, right? So this sequence for the cards is the first row had 3, the second row had 6, 9, 12. Okay, so that was our sequence. So I'm going to write that here. 3, and we're going to add 6, and we're going to add 9, and we're going to add 12, because that's our sequence, all the way up through the 20th row. That's what they're asking us to do, which is a sub 20. Okay, so the deal here is when you have to find the sum of an arithmetic series, what you want to do is you need to find this last term, okay? So if you take a look here, right? If I do, so this is 12, so this is a sub 1, right? A sub 2, a sub 3, a sub 4, right? And I want to get to the 20th term, right? So I'm going to take 12 plus 3, because that's my D, that's how it's increasing each time. That gives me 15, doesn't it? So then I would have 15. And then, so that's a sub 5 plus 3, that's 18. A sub 6, a sub 7, right? I would add 3 again, so you could use your calculator or just add, right? So it's 21. Then a sub 8, so that would be 24. A sub 9, right, would be 27. And then a sub 10 is 30, right? Okay. And then you could keep going, right? And so we have a sub 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, right? So these are all my terms here. And then a sub 20 will be the 20th. So if I keep going, this is 33, 36, 39, 42, 45, 48, right? 51, 54, 57, and then the last term in this sequence, the 20th, would be 60, right? Wouldn't it? Okay. Now, you can do that. That kind of took a while, all right? But it does make sense, right? We're just trying to find the last term here, okay? You can also, or you could write the rule, right? So if you write the rule, right, we have a sub n, a sub 1, right? So our rule is a sub n equals a1 plus n minus 1 times d. So a sub 1 is 3, right? We don't know what n is if we're writing the rule, and then we know d is 3, right? Because we're increasing by 3 each time. So my rule here would be a sub n equals 3 plus, right? So there's my d and my a sub 1. Then when I distribute, right, I get 3 plus 3n minus 3. These guys cancel, and a sub n is 3n, yeah? So therefore, if I wrote my rule, right, and I want to find the 20th term, a sub 20, right, would mean 3 times 20. So a sub 20 is 60, which is exactly what we got when we counted it. So you can do the rule, you can count them out, it depends, okay? This one was kind of tedious because it was the 20th, okay? But it's up to you, all right? Then we use our formula, right? Because it's kind of annoying to plug all these in. The formula is actually faster, okay? So the formula is S sub n, right? I'm just copying it from here, equals n times a1, an, and then divide by 2. So if you look, n is, I'm just starting here, right, is 20, right? Because we're trying to find, that's a 20th term we're trying to find the sum through. A sub 1 is 3. A sub n, since I'm trying to find the sum through the 20th, that's a sub 20. So the last term, always the bookends, I say, the beginning and the end. So a sub 20 is 60 we found, right? Then we're just dividing by 2, so I think we're good, right? So the sum through 20 terms equals 20 times 3 plus 60 divided by 2, right? And then here, I would do the parentheses first. So 3 plus 60, right? You probably know that's 63. Divide by 2. You might get a decimal. That's okay. 31.5 times 20. And we get 630, okay? So the sum through 20, we did 20 times. And then the sum through 20 was 630. Okay, so the big deal here is you have to either count out the last term or you need to use a formula, okay? Like we did on the previous page. Now these are a little bit nicer, right? It says find the sum through the 10th term. If you take a look here, they give us a bunch of these terms. You can see this is a series, right? Because I'm adding. So they gave me through 6. So if I continue here, A7, A8, A9, A10. This is a little more manageable, okay? So if I try to find each of these terms, right, and I'm trying to find the sum through 10 terms for this arithmetic series, okay? So if I use my formula, right, and I'm trying to find the first 10 terms. So we're looking for the 10th place, right? That's where the last term is in the sequence. So n is 10. Okay, so the sum through 10. I know A1 is 2 plus. A sub 10, right, the last term, well, if I do my, so what's my pattern here? I'm increasing by 3. So if this ended at 17, this should be 20, 23, 26, and 29. Okay, so A sub 10, the last term in the series that I'm going to add is 29. And then I divide by 2. Okay, so the sum through 10 is 2 plus 29 divided by 2. So 10 times 15.5, the sum through 10 terms, right? So see my little subscript there, okay, is times 10. I get 155. So your numbers are going to get a little bit bigger because you're summing here, okay? But that's your sum, okay? Let's take a look here. Yeah. This one, we'll skip number 7, okay? If I look at number, let's say 8, right? We're summing through the first 10 terms. So the sum through 10 terms. And it can be any number of terms. We're just using 10 here, okay? But if I'm finding the sum through 10 terms, okay? I'm going to use my formula again, okay? So this is n times a1 plus an over 2, okay? So the first and the last term, okay? So my sum, n is 10, because they have to tell you what number of terms to sum through, okay? So you will see that in the example. n equals 10. A1, this is A1. So I have A1 equals -4. And then if you take a look here, it doesn't ask me for D, right? But hopefully you can recognize that when I go from A1 to A2, right, I'm adding 4 each time here. A3, A4, so there's first, second, third, fourth, fifth, sixth. So then I need A sub 7, A sub 8, A sub 9, and A sub 10. So there, if I add 4, this is 20, 24, 28, and 32. So A sub 10 is 32. So the sum through 10 terms is 10 times -4 plus 32 over 2, okay? So then I do -4 plus 32 is 28, divided by 2 is 14. So that's a nice whole number. So my sum through 10 terms, and so you can see the subscripts through 10 terms. It tells the reader how many numbers you've added together, and that's 140, okay? So that's our 2 formulas for arithmetic sequences. Try the homework, and that's it. Have a good one.